Hi everyone, today let's practice our pointer diagram of array. The special part of array is, if you are looking at the address of this A, right, the address of this A is same as the first element of this array. Let's look together what do this mean, okay? Initially, right, we have an array of A, so it's going to be having a pointer. So this pointer, right, is going to point at the 4 memory address. So let's look at the 4 memory address. So initially we got 10, we got 15, we got 20, and then we got 25. Okay, it's going to be looking something like this. Then we have a B array. Our B array, right, 50, 60, 70, 80, and 90. Okay, so it's going to be like this. So as you know, right, this one is also known as A0, right? And then this one will be A3. Okay, and similarly, this is going to be B0, okay? And then this is our B3, okay? Because for our array, right, our array is starting from index 0. So for this pointer, right, if you are accessing the address of A0, it's essentially same as the address of this single A, okay? And same to our array of B, if you are accessing the address of B0, it's same as the address of B. So let's jump to the example. Let's see if we have an X array, right? Our X array with an integer pointer, right? What does this mean? This means, right, we have a pointer of X, okay? This pointer of X, right, is going to hold another 2 pointer. Let's look at this pointer. This pointer, right, is pointing at A, and this pointer is pointing at B. So respectively, A0 is A, A1 is B, okay? So respectively, right, X0 is A, X1 is B, okay? So this is X0 and then this is X1, okay? If our X0 is pointing at A, right, so the address is same as this one, okay? So it's going to be linked at here. And then our X1, right, is same as the pointer of B, right? Then this is going to link at here. Okay, let's look at another example. In the second example, right, we have integer pointer of Y array, and this Y array, right, is accessing A plus 2 and B plus 3. So what do A plus 2 mean? If we are dealing an A plus 2, right, you actually can look it like this. This actually is similar to A2, okay? So if it's A2, right, it's going to be in this position, okay? Let's draw it. So secondly, right, we have a Y address pointer, right? Our Y pointer will link an array, okay? This time it's also 2 array, okay? Look at here, you got 2 elements, okay? So this array would consist of integer pointer, okay? We consist of integer pointer, right? This one is going to point at where? This one is going to point at A2. If it's pointing at A2, right, then it's going to be pointing at this address, okay? So let's look at this. If it's pointing at B3, right, then our B3 is at this position, okay? So we have solved this part. Next, we got our pointer P and we got a pointer Q. So let's draw it out. So our P, right, let's label it. Our pointer P would be this one. And then we got a pointer Q. Our pointer Q, let's draw it here. Our pointer Q. And then, right, we have a double pointer. Our double pointer R, right? So we got an R, okay? Our R will be say located here, okay? So let's see what is assigned to P. Our P is equal to A. So what is A? Our A is this address, right? So our P will be the same as this address, okay? So let's look at Q. Q is equal to Y1. What is Y1? This is Y0, this is Y1, okay? Let's label it. This is Y0, this is Y1, okay? If you are accessing a Y1, right, Q is equal to Y1. So our Q is going to point at this address, okay? It's going to point at this address. Then let's look at our double pointer. Our R is equal to address of Q. So what is our R? Our R is the double pointer, right? It's going to point at Q. So let's draw the line. Point at this one, okay? Our R will point at Q. This is our pointer diagram. With this, right, we have already finished. Let's look at the next one. Dereference P. What is dereference P? If we dereference P, right, we are at this location. Dereference P is equal to address of P3, address of P3. If P0 is here, P1, P2, P3. Our P3 is 25, okay? Our P3 is 25. So let's put a small label. This is our P3, okay? This is our P3. Minus Y0. What is Y0? Our Y0, right, is in this one, okay? If we look at Y0, right, is equal to this address. What is this address? This address is actually is Y0, okay? This Y0. When we go to this address minus this address, right, because it's an integer array, right, if you minus the location together, what you get is actually is 1, okay? It's 1. Although integer is 4 byte, right? So example in A0, right, we have 0x0, okay? And then in here, right, our address is actually 0x4. And then, right, in this address, right, it's 0x8. Then in this address, right, it's actually 0x12. However, right, if you use P3, right, P3 minus our Y0, right, it's actually 12 minus 8 divided by 4 byte, okay? You need to divide it by 4 byte because it's an integer array. So what you get is 12 minus 8 is equal to 4. And then 4 divided by 4, right, is actually 1. So the answer of dereference P is actually 1. So when we dereference P, right, this 10, right, would need to be changed, okay? We will need to change this. So finally, right, the answer would change to 1, okay? The answer would change to 1. So we'll solve this part. Then let's look at this. R01. What do R01 mean? If we are looking at R, right, our R is this one. When we go to R0, right, we are at this position, okay? This position. When we are going to R1, right, it means go to the R00, okay? R00. And then this is R01, okay? So let's label it. This is actually same as R01, okay? So let's look at what do we want to store in R01. In R01, right, is equal to dereference R. So if you dereference R, right, it means this is 80, okay? So let's write it down. We are using 80 minus our Y01. What is Y01? Y is in here, right? When we are going to Y0, it's in this location. And if you are going to Y1, right, then we follow the pointer, okay? So in here, this is Y0, this is Y0, okay? So when we go to the next one, right, then this is Y1, this is Y1, okay? So we can label this as Y01, okay? This is same as Y01. Our Y01 value is what? Our Y01 value is 25. So the answer is 25. So 80 minus 25, right? The answer will be 55. And don't forget, right, we need to set the value inside here. So our R01, right, initially is 90. It will become 55, okay? Before you start doing this practice, right, you need to know two things. There are two types of notation variable. The first type is called as array notation. Array notation is most common people know. Example, right, if you have array of size 4, okay, size 4. If you want to access element number 3, how do you access it? Say this array A. If you want to access array number 3, right, so it's going to be A2, okay, because our index is starting from 0. 0, 1, 2. This is how you access this element. So let's look at second type of notation. The second type of notation, right, is called as pointer notation. How is a pointer notation different? Let me show you. If you are doing a pointer notation, right, if you want to access the same, you are going to do like this. the reference of a plus 2. Okay, this is pointer notation. Because if you are writing an a only, right, the a, remember, the a, right, is essentially a pointer. This pointer, right, is going to point at the first element. This is why, right, if we add 1, 2, if we add 1, add 2, so we are at this position. So when you dereference it, only then you get the value. Okay? Now let's look at 2D array. If you want to write a 2D array, right, if you want to declare it, say our C32, right, so it means, right, we have 3 row and 2 column. Okay? If you want to have a C32, how do you do it? Initially, right, you declare a double pointer. So this double pointer, right, say we call it as C. Okay? C is equal to integer of double pointer malloc of our row multiply the size of integer. So if you want to have a 3 row, right, then you use 3 multiply the size of integer pointer. So it's going to look something like this. Our C, right, will be a double pointer. Okay, this double pointer, right, is going to point to 3 integer pointer. Okay, 1, 2, 3. Okay, this is an integer pointer, this integer pointer, this integer pointer. This is the left part, C0. Okay, C0. And this is a C1, okay, and this is a C2. Afterwards, right, all you need to do is you need to allocate, okay, allocate the column, okay, because this is not yet finished yet. You want to allocate 2 columns, so you need to use a for loop, right? Access each row, and then you need to malloc it. If you malloc it, right, this pointer will point to an address like this, okay? And then this array can hold 2 items, okay? So let's say this array put 1, put 2, okay? 1, 2. If you want to fill data inside, you can use a for loop to do so, okay? So in each, right, in each address, right, you're going to set, okay? Set size 2, okay? Malloc it. So this example, this is 3, 4. And then, right, we have another, okay? Another array, say 5, 6. And our 2D array has completed. So with this, right, how do I get the value 5? If I want to get the value 5, right, you know already, to get the value 5, the array notation is using C20, okay? This using the array notation. If you don't want to use array notation, how can you do it? The answer is, what you need to do is dereference it first. If you want to dereference, right, go into the C2, right? This is how to do it, okay? So you want to dereference, okay? I know you want to dereference, but inside the bracket, right, you are adding, okay, C plus 2. This is the notation. Although, right, although the hexadecimal address is not A2. Example, this is 0x0. This one is maybe 0x4 because integer is 4 byte. But when you add 2, right, the C language, right, will automatically go to this position, C2, okay, C2. After we go to C2, right, then only it go to 0, okay, position 0. Then we add with 0 and dereference it again. So when you dereference it again, right, when you are at here already, you dereference it again, then only you get 5. If you want to mix array notation with pointer notation, right, what you can do is, you can write like this, C2 add with 0, and then, right, you dereference it, okay? You dereference it. So when we at C2, right, when we go to C2, right, we are at here already, okay? C2 is a pointer, okay? So when you add 1, 0, right, you add 0, you're at this position. Only then you dereference it. Only then you dereference, so you will get this, okay? Okay, now let's look at 2D array. If you want to visualize the 2D array, right, it's going to be like this. If it is a C54, right, the 5 is actually a row, okay? This one is a row, and the right side, right, this one is a column, okay? So this means, right, we actually have 5 rows, 4 columns, okay? So let's do like this, 1, 2, 3, 4, 5. We got 5 rows, and we got 4 columns, okay? So let's draw a pointer diagram. If you want to visualize a pointer diagram, right, it's going to be something like this. C, right? C, we have a fuse pointer. So initially, right, we have a 5 pointer, okay? 5. 1, 2, 3, 4, 5, okay? So we got pointer 1, pointer 2, pointer 3, pointer 4, pointer 5. Let's label it, shall we? This one, right, is actually C0, okay? And then, right, this one is going to be C2, okay? And then this one is C4, okay? So C4, right, C4 is our fifth element, okay? And then, right, we are going to draw 4 columns each, okay? So our column, right, so let's label with the index first. So we have index 0, right? This is the first element, second element, third element, fourth element, okay? So let's draw the table, okay? If we draw the table, right, it's going to be sized like this also, okay? 5 row, and then, right, we have 4 columns. So this pointer, right, is going to link to this array. Okay, so this pointer, right, is going to be linked like this, and this pointer is linked to the second one. It's going to be linked like this. Okay, so if we are calling a C00, right, this essentially is like this. If you are calling the first one, it's going to be C00. Read it like this. So let's practice the exercise. If you are calling C21, right, so the answer is we are calling C2, follow the C2, and then we're going to the C21, okay? C21, okay? If you're C21, right, then the answer will be 10, okay? The answer will be 10. It's going to be like this. Square bracket C21, right? The answer is 10, okay? The answer is 10. So let's look at C. What is C? Our C, right, is actually an address, okay? If we just print our C, right, it's actually the address of C0, okay? It's the address of C0. So let's continue. What is the C2? If we print C2 only, right, it's essentially the address of this one, okay? Address of C2. Before we proceed to question D, right, there's one thing I need to tell you. The address is stored in the form of hexadecimal. In hexadecimal, right, after 10, right, decimal 10, right, is represented using an A, okay? So meaning 10, 11, 12, 13, 14, 15 is actually A, B, C, D, E, F, okay? This hexadecimal. So this one, right, so example, this one is 0x0, right? 0x00, okay? So this one is 0x04, 0x08, 0x012. But remember, in 12, right, it's actually C. So this one is actually 0x0C, okay? 0x0C, and then when we reach 16, right, 16, after F, right, we back to the number. So this one is 0x10. This one is 0x10, 0x14, 0x18. This one is 0x1C, okay? 0x1C, 0x1C, and this one is 0x20, okay? 0x20. And then this one is 0x24, and so on and so forth. Okay? I hope you can see how we count this. So let's look at this. In here, right, we are using C plus 2. What is the value of C? The C, right, the C address is actually same as C0, okay? Can you see this? The address of C, right? C is pointing at the first element. If we did not dereference, right? If we did not dereference, we are actually not going in this direction. We are not traversing in this direction. We are not going in here. If we did not dereference, right, that means, right, we are going forward, okay? Going like this. So we are at C2. So the address of C2, right, is actually 0x20, okay? This one is 0x20. So let's look at this. If we C plus 2, right, we go to C plus 2, we are at here. And then we dereference, right, we dereference one time, what is the value we get? The value is still 0x20, okay? So it's 0x20. So then let's look at this, C2. And remember, right, in the array notation is actually same to pointer notation that is already dereferenced. So C2, right, at C2, we already dereferenced, so we are at here. Now we are at here, right, so we add 1. What did we get? If we add 1, right, we are advancing to this location. What is the address of this? 0x20 plus 4 byte, then we get 0x24, okay? So the address of this is 0x24, okay? Now let's look at question G. Question G is C2. So we go to C2 again. And remember, if it's in array notation, that means we already dereference, so we're at this position. Okay? And we go to C2 plus 1. Okay? If you are at C2 plus 1, right, that means we would advance one time. If we advance one time, right, we are at here. Okay? We get this address. And when we get this address, right, when we dereference it, then we will get the value of 10. Okay? The value of this one is 10. Then let's look at this C plus 1. The reference of C plus 1. This one, right, is actually same as C1. Okay? This one is same as C1. So let's go to C1. When we are at C1, right, when the reference one time, right, we are at this address. Okay? We are at here. So we advance two time. Okay? Advance two time, one time, two time. We are at here. Okay? So when we dereference it, what did we get? We get the value of 7. Okay? We get the value of 7. So this one is 7. So let's go to C06. This one is easy and straightforward, right? So we go to C0. We dereference one time. We are in here. And then, right, 6. What is 6? So we get advance one time, two time, three time, 4 time, 5 time, 6 time. When we advance 6 time, right, what is the value we get? We get the value of 7. Okay? Because this is continuous block. Okay? Continuous block. Supposingly, if we can allocate the array in a continuous block, right? If we didn't malloc it ourselves, right? We are supposing getting a continuous block of address. Continuous. Okay? It will be continuous. So that means, right, the value is 7 also. Let's look at the final question. C plus 2. What is C plus 2? If C plus 2, right, it did not dereference, that means we are trouble in this position. So we are going from C0 at 1, 1 time, 2 time. Then we are at here. And then, right, we advance one time again. If we advance one time again, we are at C3. Okay? We are at C3. In C3, after we add C3, then we dereference. If we dereference one time, right, we get this address. What is this address? So it's going to be 0x30. Okay? The answer of this one is 0x30. With that, we have finished our practice. I hope you understood what I've said so far, and I hope you like this video. Bye bye.